Welcome to this channel. If you are new here, consider subscribing. As always, don't forget to turn on the notification bell so that every time I post a new material, you'll be notified. In this video, we are going to revise organic chemistry ECZ questions from 2015 to 2023 GCE. If you are writing your exams soon or in the near future, this is the right platform for you. Okay. Let us start. So we are going to start with question 1. In this series, question 1 comes from 2022 GCE. Bear in mind that the questions in this video are arranged according to the topic, the advancement of the topic, starting with alkanes, alkenes, and all the way to end with macromolecules. So the first question that we are starting with, that is on alkanes, is coming from 2022 GCE paper. So here is the first question. The 4 hydrocarbons are member of a homologous series. The 4 hydrocarbons given are members of a homologous series. That is, we have this first one, we have the second one, and the third one. Okay? So we should start by identifying them. So the first one from alkanes, the first in the series is called methane. This is the 4th one. Carbon 4 is called butane, and this is decane, the 10th one. So the first question that we are answering in this case is explain the term hydrocarbon. In this case, the answers I'll be giving the answers orally. Where I need to write, I'll write. So you need to pay particular attention. So what is a hydrocarbon? So a hydrocarbon is just a compound that contains carbon and hydrogen only. A compound that contains carbon and hydrogen only. That is how you define a hydrocarbon. Okay? So the next question that we are answering is question B on 1. To which homologous series? To which family do they belong? So in this case, they belong to alkanes family. So they belong to alkanes family. So that is the answer for B1. What about B2? Name the compounds with molecular formula C, with this molecular formula. Name the compound with the molecular formula C4, that is C4H10. What is the name of this compound? So this is called butane. So you just needed to write butane. So the compound is called butane. That is B2. Let us look at part C of the question. So part C of the question is draw the full structural formula of the hydrocarbon which has 4 carbon atoms. We are drawing the structure. So every time you are given such a question, you need to draw a structure. Now in this case, they've told us that the structural formula of the hydrocarbon that has how many carbon? 4 carbon. Okay? So 4 carbon, which means C is 4. The general formula, please, is C N2N plus 2. CnH2n plus 2. That is the general formula of alkane. So if they tell you 4, you just insert 4 where there is N. So in this case, it will be C4H, 2 multiplied by, in this case, 4 multiplied by 2 is 8. 8 plus 2 is 10. So now, this is the molecular formula. We want the structure. So how do you put it? So you start by drawing the carbon chain, 4 of them. You know that alkanes, they have a single bond between a carbon and a carbon. So you have 4 carbon connected, and now you connect the hydrogens around the carbon. Bear in mind that 1 carbon should be attached to how many bonds? 4 bonds. Okay, so you have to ensure that. So this is the structure that you are looking for. So this is what you are asked to draw on that question C, 1 mark. Let us look at D. Which of the given hydrocarbons has the highest boiling point? Which of the given hydrocarbon has the highest boiling point? Okay, so just to give you the hydrocarbons that we are looking at, we have methane, we have butane, we have decane, okay, C10H22. Which of these has highest boiling point? Now look, as the number of carbon increases, also the boiling point increases. As the number of carbon increases, also the density increases. So the physical properties change according to, as the number of carbon increases, their physical properties. In this case, we are talking about density, talking about molecular mass, we are talking about boiling, we are talking about melting. All these increase as the number of carbon increases. So we are looking at the one that has a lot of carbons, and that is the one that has the highest boiling point. So here on D, you just put this one. It's the one that has highest boiling point. All right, let us look at question 2. Question 2 of the questions that we are solving today. So question 2 is here. Petroleum is a complex mixture of hydrocarbons. Petroleum is the complex mixture of hydrocarbons. Petroleum is the source of many fuels. The first question we are answering is, that is A1, define a fuel. Define a fuel. So a fuel is a substance when burned produce heat energy. It's a substance when burned produce heat energy. That is how you define a fuel. The second question is, what is meant by the term hydrocarbon? That is A2. What is meant by the term hydrocarbon? Now, even the question that we are from looking at, we define hydrocarbon already. Okay? So a hydrocarbon is just a compound that contains carbon and hydrogen only. That is how you define it. And you get a 1 mark for that. Let us look at B of question 2. Petroleum is separated by fractional distillation. Name the fractions with the lowest boiling point. Name the fraction with the lowest boiling point. Okay, so in this case, the fraction with the lowest boiling point is called refinery gases. Refinery gases are the substance with lowest boiling point, and we are looking at hydrocarbons that have a carbon number of carbon from 1 to 4. Those are what we call refinery gases. Okay, if you want more understanding, you can review the previous video that I've made on alkanes. Everything is explained. Then what about the one with highest? That is B2, the one with highest. Name the fraction with highest boiling point. So the one with highest boiling point is bitumen or asphalt. Okay? So the one with the highest boiling point is called bitumen or asphalt. Let us look at question C. State one use of petrol. State one use of a petrol. Used as fuel for petrol-based cars. What about paraffin waxes? So one of the use of paraffin waxes is to make in making of candles. You can add also making of polishes, making of other cosmetics. Those are the uses of paraffin waxes. Making of candles, making of cosmetics, making of polishes. Okay? Let us look at question D. An alkane molecule is cracked and it yields the two molecules. An alkane molecule is cracked and it yields two molecules. What are the molecules that are yielded here? C5H12 and C3H6. These are two molecules that comes out from cracking. You know that cracking is breaking of large hydrocarbons. So in this case, what it means that after breaking this large hydrocarbon that we don't know, I'll put X, what the products that are produced are this one and this one. Okay? Just to name them, this is propene and this is the pentane. Pentane. So pentane and propene are produced when this substance that we don't know is cracked. So now how do you know the substance? What is the question? What is meant by the term cracking? So here we are defining what cracking is. So what is meant by the term cracking? So cracking is the breaking down of the large and heavier complex molecules, okay, or hydrocarbons into simpler and lighter molecules. It's the breaking down of the larger, heavier and more complex hydrocarbons into simpler and lighter molecules. So that is cracking. State two types of cracking. Okay, so in this breaking down of large or larger molecules, two methods are used. So you can use heat, which is called thermocracking. So one type of cracking is called thermocracking. And again, you can use a catalyst, but with less heat. Use of a catalyst with less heat, and that is called catalytic cracking. So two types of cracking, we have thermocracking and catalytic cracking. Write down the two possible products when the compound given there is cracked. So the compound given is C11H24. So what are the two possible products that are produced when this compound is cracked? Okay. So in this case, what is produced, you take into account number of carbon. So for me, I'll start, let's say, what if we say one of the product that is produced is the butene. Now, if butene is produced here, one of the product produces butene. Out of 11, we remove 4. You remain with the 7 carbon. Then now, out of 22, if you remove 8, you are going to remain with 16. So H16. So these are two possible products that are produced from this one. Taking into account, if you count the number of carbon, 4 plus 7 to give you 11. And 24, 8 plus 16 to give you 24. So the possible products are these, okay? These are the possible products of when this compound is cracked. So the two possible products are these, okay? Give too many reasons why cracking is important. So why do you think cracking is important? We are breaking down large molecules into smaller ones. What is the importance of the process of cracking? So one of the reasons why cracking is important is that you need to convert large hydrocarbons into smaller ones. You need to convert large hydrocarbons into smaller ones, because the smaller ones are the ones that are on demand. So you need to convert the large into smaller ones. The next one is that you need to meet demand for small hydrocarbons. Now, small hydrocarbons such as petrol, they are mostly used, okay? Like we said, these are used in cars, those cars that use petrol. So we need a lot of them, okay, so that we can meet the supply and the demand. So that is another reason. All right, let us look at the other one. Give that molecular formula of the compound which was cracked to produce the two compounds. We are going back to this question where we have pentane and propene. Now they're asking us, give the large molecule where this one is coming from, okay? Where these two are coming from. So you just add the number of carbon. Here is 5, here is 3. So number of carbon, 8. You are remaining with the hydrogen. 6 plus 12, it will give you 18, okay? So this is the compound that was cracked. And this is called octane, okay? Let us look at the next question. Describe how you would distinguish between alkanes and alkenes. Describe how you would distinguish alkanes and alkenes. So distinguishing is just to look at what are the differences that are there between alkanes and alkenes. So one of the differences is that alkanes, they have a double bond between a carbon and a carbon, whereas alkanes do not have. That is one of the difference that is there, okay? And that difference, that double bond is what we call the functional group. Then the other difference that we can look at in terms of when you use bromine water to test for alkenes is that alkanes decolorize bromine water or bromine solution. Bromine solution by color is red. When you add alkenes to bromine solution, it turns colorless, whereas alkenes do not. Okay, so those are the two differences. Alkenes have the double bond between carbon and the carbon, whereas alkanes, they have a single bond. Then we can look at also the way they behave in the presence of bromine solution, where alkenes decolorize the bromine solution while alkanes do not. Okay, so that is one of the difference. Those are some of the differences that we should take note. Draw the structural formula of one alkane and one alkene. So this is the first one I'll draw for an alkane. So in this case, an alkane that I'm going to draw is the structure for propane and propene. Give the IUPAC name of an alkene. So the systematic name of an alkene, how do we name this alkene? So you look at, actually here we have a position isomer, where we look at the position of the double bond. Okay, so how do we name this one? So we name it according to the position of the double bond. So if we count from here, number of carbon, the long chain has 3 carbon. So if we count from here, 2, 3, the double bond will be at position 1. But if you count from here, the double bond will be at position 2. We want the one with the lower number, so we are going to use counting from this side going this side. So what is the name? So the name is prop. Okay, prop dash 1. The double bond is at 1 in. So this is the IUPAC name. That is how you name it systematically. Okay, let us look at the next question. So for question 3, we look at question 3. Start the following series of reaction for ethane. So study the following series of reaction for ethane. Okay, so now here, this is, I think this diagram is clear from this one. So here we have liquid F, which is liquid F here, and we have acid bromine on top, we have water, we have ethene, then we have add gas A here, excess of oxygen, then ignite, then we have add gas C, condition, then the product here, there's chloromethane. So that is what is here. The product here is chloromethane. Okay, now in studying these series of reaction, before you answer the question, you need to trace where the arrows are pointing, and that is how the reaction flows. So in this case, on question 3, the first question that we are answering is identify gas A. So gas A is here, where you add gas A here, add gas A. So to ethene, if you add, the reaction is going this side where the arrow is pointing. When you add gas A to ethene, it produces ethane. What could be gas A? So the only possible gas here is hydrogen, because this is hydrogenation reaction. Alkenes undergo hydrogenation reaction. What is produced are alkanes. In this case, ethene turns to ethane. So now, gas A, we are saying, is the hydrogen. What about gas B? Gas B is here. When this ethene undergo the process here, please, here there's plus steam. So gas B is here. When ethene in the excess of oxygen is ignited, is burned. To ignite is to burn, produces gas B plus steam. Steam here we are looking at water in vapor form. So it's just the same as the gas A and water. So combustion reaction always produces carbon dioxide and the water. So in this case, gas B is carbon dioxide. Okay. Then what about gas C? Ethane, when you add gas C, it produces chloroethane. Just from the prefix here, chloro is chlorine. So gas C is chlorine. So here, gas C is chlorine. Here we said hydrogen, carbon dioxide. Then here we have chlorine. Then what about condition D? Now, ethane are converted to chloroethane. In this case, gas C is a halogen, so that is halogenation. This occurs in presence of UV light. Okay, in presence of UV light or high temperature. So the answer there is UV light. That is condition D. Then what about liquid F? Liquid F, we are saying, is a dibromoethane. Then what about liquid E? Liquid E, where is liquid E? Liquid E is here. So when ethene plus steam, this reaction is called hydration reaction. So what is produced here is ethanol. Okay, so there is ethanol. Write the balanced chemical equation for the reaction of ethene with excess oxygen. So that is complete combustion, burning of ethene in a full supply of oxygen. So you are going to have ethene plus oxygen. What are we going to produce? Carbon dioxide plus water. Okay, so carbon dioxide plus water are the products. Now we want a balanced one. So here you add a 3, here you add a 2. I mean here is a 2, then here a 3. So 3, 2 are 2. Okay, this is the balanced equation for combustion reaction. Okay, then give the structure formula of liquid E. You are giving the structure formula. Liquid E, we said, is ethanol. Therefore you are giving the structure formula of ethanol. Okay, so ethanol has 2 carbon OH attached to it, which is a functional group. That shows that these are alcohol. Okay, so this is how you draw the structure of ethanol. Okay, state the industrial application of the reaction of ethene with gas A to form ethane. So we are looking at what is the industrial application of hydrogenation. So from ethene, gas A is added to produce ethane. So what is the industrial purpose, or what is the industrial application of ethene? So the industrial application is that, so it is used in hardening of vegetable oil to form margarine, used in petrochemical industries. Those are 2 industrial purposes of industrial importance of hydrogenation. Okay, let us turn to question 4. Question 4, we are saying a propene is one of the many important hydrocarbons obtained. Okay, propene is one of the many important hydrocarbons obtained from crude oil, like propane. It is made up of molecules which contain the 3 carbon atoms. Draw the structure formula of propane. Draw the structure formula of propene. So the formula of propene, you know that it's a hydrocarbon with 3 carbon. In this case, an alkene. So a double bond between the 2 carbon. Okay, and bear in mind that a carbon should be attached to 4 bonds. So this one is attached to 4, this one is 4, this one is 4. So this is the structure of propene. Okay, that is how you draw it. At least between the 2 carbon, there should be a double bond. Then what is the next question? The next question that we are answering, that is the A2. Does propene differ from, how does propene differ from propane in terms of bonds? So in terms of bond, if you look at propane is like this. Okay, it's like this, where hydrogens are connected here. So this is propane. Now, how do they differ in terms of bonds? Here, the question is specific in terms of bonds. Now, look at this. The bonds in propane, they are single bonds. But between carbon and the carbon here, there's a double bond in propene. So in terms of bond, we are saying propene has a double bond between a carbon and a carbon, but whereas propane have single bonds between, or single bond between carbons. Okay. A3, that is question 4, A3. To which homologous city does propene belong? To which homologous city does propene belong? So propene belong to alkenes. Belongs to alkenes. Okay, so propene belong to alkenes. That is the answer. Give the molecular formula of propane and propene respectively. Give the molecular formula of propane and propene respectively. So we are writing the molecular formula of propane and propene. So these are the ones. Propene is this one, propane is this one. So these are the structures. Okay. Explain why propene, that is B4, question 4B. 1. Explain why propene reacts immediately with bromine water, whereas propane does not. Explain why propene reacts immediately with bromine water, whereas propane does not. Now, the answer to this question is that this is because propane is unsaturated hydrocarbons. The double bond break, leaving room for attachment of bromine. Okay, leaving room for attachment of bromine, whereas propene have stable bonds. They are unsaturated. They cannot react with bromine. So that is the reason why propene react immediately with the bromine water. Okay. Then B2, describe what would be observed during the reaction. So when bromine water, when propene, as discussed already, when propene is put in bromine water, it decolorize. Bromine water is brown in color or red in color. So when you add propene, it becomes colorless because all the bromine has attached to propene and no bromine is left in the solution. Hence, the solution turns colorless. Then C, propane is obtained by breaking down longer chains of hydrocarbons. What is this process called? So this process is called cracking. Propene is the monomer for making an important plastic. State the name of the polymer it forms. So propene form what we call a polypropene. Okay? Polypropene. Polypropene, like this. That is the polymer it forms. Let's look at question 5. A hydrocarbon V, which contained only 3 carbons atoms, was bubbled through bromine solution, and there was rapid decoloration of the solution. Identify the hydrocarbon V. A hydrocarbon V which contained 3 carbons. So a hydrocarbon V. So the keywords here to help you to understand the question or to give the correct answer is that on alkenes are the ones that are tested using bromine solution or water. So therefore we are dealing with alkenes. Now here you are dealing with an alkene with 3 carbon, which is a propene. So identify the hydrocarbon V. In this case the hydrocarbon V is the propene. Okay, draw the structure of the hydrocarbon V. So the structure of hydrocarbon V, since we are saying it's a propene, so here we had drawn the propene. So this is the structure, a propene, 3 carbon, this is a propene. Okay, to which homologous city does the hydrocarbon V belong? It belongs to alkenes. So the answer here, it belongs to alkenes. Write the general formula of the homologous city where the hydrocarbon V belong. What is the general formula for propene? So the general formula for propene is CnH H2N. Then the next question is, explain the dangers of burning hydrocarbon V in limited supply of oxygen. Now, combustion reaction, if there's a lot of oxygen, plenty supply, excess oxygen, the products always is carbon dioxide and the water. But in the case where there's limited supply, short supply, which means there's not enough oxygen, therefore carbon monoxide and water are produced. Now explain. So in this case, we are looking at the gas, which is carbon monoxide. So carbon monoxide is a dangerous gas, okay? It destroys brain cells. How does it do it? It binds the hemoglobin and it is transported to the brain instead of oxygen, starving the brain of oxygen. And therefore the brain cells, they start dying. So it destroys the brain cell. That is one of the effects of carbon monoxide. Okay? Write the balanced chemical equation for the reaction above. Which reaction are they asking here? So the reaction is therefore is for incomplete combustion of propene. So the equation is C3H6 plus oxygen. What are you producing? Carbon monoxide plus water. So here 3 balances, 3 here, 3 here. So this is the balanced equation for incomplete combustion of propene. Okay. Under suitable condition, the hydrocarbon V was polymerized and polymer W was produced. Display the structure of polymer W. So the polymer W that we are looking at, the monomers or the smaller units are propene. So we are looking at the hydrocarbon, the polymer containing propene as monomers. So in this case, we can display it like this. So this is a propene, the way you can write it, exposing the double bond. A propene has 3 carbon, 1, 2, even this one is a carbon, 3. Also you draw another one, a double bond, like this. Then when these attach, the double bond break and leave room for attachment. So the long chain will have 4 carbons, and of course the space will be left there to show that more carbon can attach. So in this case, what you have here, CH3, this part. Then here you have hydrogen. Here on top you have CH3. Here you have hydrogen. So this is the polymer, just showing 2 monomers. But here you should leave these spaces showing that more propene attaches. Okay, so that is the displayed structure on question C. That is under suitable condition. The hydrocarbon V was polymerized and polymer W was produced. Display the structure. So that is the structure that is needed there. Question 6. Butene is a compound belonging to alkene series. Explain that butene C4H is the compound. So this compound butene is a compound belonging to an alkene series. State the general formula for alkenes. So the general formula for alkenes, please, CnH2n. So this is the general formula. That is the answer that you needed to write there. Okay. Then draw the displayed structure of a second member of the series. So the second member of the series. Now, alkenes, they do not have 1 carbon alkene. There's no 1 carbon alkene. It starts from carbon 2, carbon 3. So the first one is this one. The second one is this one. So they are asking you to draw the structure of propene. And the structure of propene here is this one. We've drawn it several times. Okay. So that is the structure of propene, the second member in the series. Butene is prepared by cracking petroleum oil. Butene is prepared by cracking petroleum oil. Name the other method by which it may be prepared. Name the other method by which it may be prepared. So now, aside from cracking, how are the alkenes prepared? That is the question. Aside from cracking, we are looking at alkenes because butene is an alkene. So aside from cracking, the other method is dehydration of alcohol. Dehydration of alcohol. So here, the method that we are looking at, since cracking is mentioned, so we can only resort to go for dehydration of alcohol. Now, but1N can be polymerized. Name the type of polymerization it undergo. So all the alkenes undergo addition polymerization. All of them, they undergo addition polymerization. So the answer here is addition polymerization. Draw and give the name of the polymer formed from the but1N. Show at least 3 repeating units. Hydrogen. So this is the polybutene. It is called polybutene. So this is the displayed structure showing 3 monomers. Then question E, that is on question 6. Butene react with steam in the presence of catalyst to form a colorless compound. Name the compound formed. So in this case, every time butene react with steam, this is called hydration reaction. Hydration reaction. And what is produced is butanol. Okay? So alkenes undergo hydration reaction to produce butanol. Okay? So the answer is butanol here. Write the balanced chemical equation for the reaction between ethanoic acid and the compound named in B above. Include state symbols. So we are looking at now the reaction of the compound that we've named in E1. E1 we said is butanol. Okay? Butanol. Now we are writing the balanced chemical equation between the reaction between ethanoic acid and the compound, which is butanol. So this is how we write it. So butanol C4H9OH plus ethanoic acid. In this case, what is the condition? Concentrated sulfuric acid producing butyl ethanoate. So this is what we are going to produce, plus H2O. Okay? This equation is balanced because if we are to look at number of carbon here, we have 4. We have 5, 6. 4, 5, 6. So the number of carbon is balanced. So this is the balanced equation for the reaction above. Okay? Let's look at question 7. Question 7, in this case, question reads, propene react with steam to give the major product. React with propene to give the major product prop1 or prop2O. State the essential condition in this reaction. So that is question 7. What are the important condition in this reaction? Okay? So the essential condition, you need a catalyst, which is phosphoric acid. This is hydration reaction. So in hydration reaction, you need a catalyst, which is phosphoric acid, and the temperature of 300 degrees Celsius, pressure of 60 atm. All right, let us look at question B of question 7. State the kind of reaction that occur between propene and the steam. State the kind of a reaction that occur between propene and the steam. So this is called hydration reaction. Okay, so that is the kind of reaction that occur between propene and the steam. It's called hydration reaction. You're adding water. Okay. However, there is also a minor product formed in such a reaction. So in this reaction where prop 2 and or propanol is produced, 2-propanol is produced, there is a minor product. Give the full displayed structural formula of the system and the systematic name of this byproduct. So when propene react with water, what is produced is the major product, which is prop. So the major product is propan dash 2O. Then we have also a minor one, which is propa dash 1O. So this is the minor. Okay. So they're asking us draw the displayed structure of the minor, which is prop 1. No. Okay. So we're just drawing the structure of propan. So this 1O, it means that the functional group is at carbon 1. That's what it means. And in this case, how do you know that this is the minor product that is produced? So if you look at the way propane is, it has between the two, let us focus on this part, between the carbon and the carbon, double bond. Okay, so this one is not supposed to be there, please. So we have a carbon that has 2 hydrogens and a carbon that has 1 hydrogen. So now water is H and O. When this reaction of hydration occurs, hydrogen is likely to attach to a carbon that has a lot of hydrogens. We are comparing these two. So this one has only 1, this one has 2. So likely hydrogen will attach here. Therefore, OH, which is the hydroxyl group, will attach on this carbon, therefore making this major product. But also, hydrogen, OH, can be here, and that is the minor product that is produced. Okay, so that is the minor product, and that is the displayed structure. Okay, how is the major product separated from the minor product? Okay, so it is separated by fractional distillation, because the minor and the major product have different boiling point, and therefore they can be separated through a fraction distillation. Okay, so that is how it is separated. If 21 kg of propane is reacted with steam, 21 kg of propane is reacted with steam, calculate the mass of propan 2 that would be formed. Calculate the mass of propan 1, 2 that would be formed. So in this case, for us to calculate the mass, let us first write the equation. So the balance equation will be C 3H6 plus 3H2O, in this case giving you 3C2H5O, okay, producing that alcohol, the major one. So this is the balanced equation for hydration in this case. Now we are going to use mass to mass, because here we want to find the mass of this one. So let us use mass to mass relation. So here we are given 2 of propane, okay? So 2.1 kg of propane of this. In terms of mass, what will be this? Okay? So now mass to mass, let us find the molar mass of this propane. And carbon is just the 3. Carbon times 3 times 12, I mean carbon is 12 times 3, there are 3 of them, to give you 36. Then 36 plus 6 to give us 42. So 42 grams. So you find the molar mass and you treat it as a mass. So 42 grams of ethene produces, what is the molar mass of ethanol? The molar mass of ethanol is 46 of ethanol. So 42 gram of ethene produces 42 gram of ethanol. What about 21 or 2.1? So this 21.1 kg in gram, it will be, we convert it into gram, it will be 2100 gram of propane is going to give us X. If we cross multiply here, 42 X is equals to 9,000 or 96,600. Okay, this side, divide 42, X is going to give us 2,300 gram. We convert this one into, kg, simply by dividing 1,000, it's going to give us 2.3 kg. So therefore, if 2.1 gram of propane is fully reacted with steam, it will give us 2.3 gram or kilogram. State the general formula for alkenes. So the general formula for alkenes here is CnH2n. That is the general formula. Okay? Let's go to question 8. Name the polymer. So the structure displayed below is the polymer that was formed from monomer Y. So that is the polymer that was formed from monomer Y. Name the polymer Y. Now look at this. This polymer, how many carbon are they? 1, 2, 3, 4. Okay? There are 4 of them. And here, this first one, if you are to cut it here in the middle, this first one has how many carbon? 1, 2, 3, 4. 1, 2, 3, 4. So this one has 4 carbon, this one has 4 carbon. So therefore the monomer with 4 carbon is called butene. The polymer here is polybutene. Then if you look at the monomer, you look at how many carbons are there in this polymer. If you were to cut it into 2 here, 1, 2, 3, 4, 1, 2, 3, 4. Therefore the monomer is butene. Okay? Construct the displayed structure of monomer Y. So displayed structure of monomer Y is this one. That is the displayed structure of monomer Y, which is butene. Okay? Monomer Y was reacted with steam under suitable condition and an organic compound Z was produced. So every time you hear of alkenes reacted with steam, what is produced is alcohol. That is the one that is produced. That is a hydration reaction. So in this case, since it was butene, so the alcohol become butanol. Okay? So the question, just to make you aware that even as you answer the question, you have this information in your mind. To which homologous series does the compound Z belong? It belongs to alcohol or alkanes. Since we are saying it's butanol that is formed, so it belongs to alcohols. Write the general formula of the homologous series, CnH2n plus 1 OH. That is the general formula. Okay? Then we have question 9. Ethene, which is this one, is unsaturated hydrocarbon. It is manufactured from petroleum as shown in the diagram. So we have a scheme here. That is question 9. We have a scheme here. Name the two processes, Y and Z. What is so petroleum is here, crude oil, which contains a number of fractions. It is separated here, kerosene is separated from this one. By what method? So naming the method or the processes, this one is fractional distillation. Okay, fractional distillation. Then what about when kerosene is now converted to ethene? Kerosene is a large molecule, converted to ethene, a smaller molecule. This is called cracking. Then we have ethene now through process Z is converted to polyethylene. Polyethylene is the polymer. So this is the polymerization or additional polymerization. So process Z is the additional polymerization. So that is process Z. Then now describe either process X or Y. Include necessary condition for any reaction. Describe either process X or Y. Okay? So in this case, they're asking you, you can describe either process X. Process X, we said, what was process X? Fractional distillation. Now, fractional distillation uses the property of a different boiling point. So the condition there is temperature. So they boil at different temperature. So fractional distillation, just looking at the process by which these fractions are separated by the use of their boiling point. Okay? Process Y. What is process Y? Process Y is cracking. Said process Y is the cracking. So now what happened? Cracking is just a breaking down of large and heavier or complex large molecule into smaller ones. What are the conditions? The conditions in this case, they should be a catalyst, which is aluminum oxide or silicon oxide. Those are the conditions for cracking. Also, you should have heat in terms of, in the case where there's thermal cracking. So there's in the catalytic cracking, we have a catalyst, aluminum oxide and silicon oxide. But in the case of thermal cracking, you have heat as conditions. Okay? So that is how it is done. Process Y is cracking. Then what about Z? Just to describe them all, what about Z? Z is polymerization. And in this case, what do you need for polymer to form in this additional polymerization? What are the conditions? So polymerization, we are just looking at additional polymerization, just looking at joining of these unsaturated hydrocarbons, normally alkenes, to form a large molecule called a polymer. What are the conditions? Temperature and pressure. They are the conditions for addition polymerization. Okay. So we continue with the question, that is question 9. This time around we are answering the question on C. Ethene can undergo hydrogenation process with hydrogen. Write the reaction equation using displayed structure. Write the reaction equation using displayed structure. So we are looking at the process of hydrogenation. So using displayed structure, we have ethene. This is the structure for ethene. Plus hydrogen. Then here you are forming. So this is the formula that you need using displayed structures. So this is what you need. Ethene plus hydrogen to form ethane. Okay. Question 10. The structure below is for a polymer. A structure below is for a polymer. Looking at this question, name the polymer. So we have hydrogen here, hydrogen there. So this is CH3 down here. This is hydrogen, 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 hydrogen. CH3, CH3. This is hydrogen. This is hydrogen. So now, here, if you cut this in two pieces, because here you have hydrogen, here hydrogen, CH3 hydrogen, CH3 hydrogen, CH3 hydrogen. So if you cut it, one polymer, one monomer will be like this. CH3 hydrogen, like this. If we were to bring it, if we were to cut it, okay? So name the polymer here. The polymer here, we look at the monomer first. The monomer surely is propene. The polymer is propene. Because if you look at this monomer, has how many carbon? 1, 2, 3. So this is called polypropene. Name and draw the structure formula of the monomer for the polymer. So this is the monomer. Okay? So this is the monomer, which is question A2. B1, state the type of polymer that is shown above. So all alkanes undergo additional polymerization. So it's an additional polymer. Additional polymer. Give one use of the polymer. Okay? Give one use of the polymer. So what is the use? It is used in making of plastics. Used in making of plastics. Also used in making of insulators. Used in making of plastic packaging. That is, or those are the uses of polypropene. Ethanol, that is, we are on question C. Ethanol is an alcoholic beverage which can be brewed from cassava. Outline the process by which ethanol can be prepared. So outline, just explaining how ethanol can be prepared. Since you are saying it's prepared from cassava, how is it prepared then? So cassava is crushed. That is the process I'm describing it. The first step is that cassava is crushed and pressure cooked to release starch, which is glucose. Then mixed with water and yeast, then allowed to react for a few days. This happens in the absence of air. Absence of air, we are looking at oxygen, at a temperature of 37 degrees. The enzyme in the yeast will help to convert the starch into ethanol, and carbon dioxide gas will be produced. I will describe that once more. Cassava is crushed and pressure cooked to release starch, then mixed with water and yeast, then allowed to react for a few days in the absence of air at a temperature of 37 degrees. The enzymes in the yeast will help to convert the starch to ethanol, and carbon dioxide will be produced. So that is the process, how it is done when you are preparing alcohol or alcoholic beverage from ethanol. Ethanol is used as a fuel. Construct the balanced chemical equation for its complete combustion. Ethanol is used as fuel. Construct the balanced chemical equation for its combustion. So you are constructing the balanced equation for ethanol. Okay? So the balanced equation, just to write it here, it will be C2H5 ethanol plus oxygen. What is produced? Complete combustion, carbon dioxide plus H2O. So here, 3 in front here, 2 here, and 3. This is the balanced chemical equation. Let us look at question 11. The following diagram shows some of the reactions of ethanol. The following diagram shows some of the reactions of ethanol. Name the structure formula of ethane. Name the structure formula of ethane. So this diagram shows that this is ethanol, and here going this side, this is solution P, this is process Q, ethene, this is water, ethanol to gas R, complete combustion here. Name the structure formula of ethane. Okay, so the structure formula of ethane is just this one, ethane. So this is the structure formula of ethane. The solution P. What is solution P? Now, ethanol, when it undergo oxidation, here is saying that it's showing that ethanol undergo oxidation, the arrow is going this side. What happened? It is converted into acid. So that one is ethanoic acid. So solution P is ethanoic acid. Gas R. What is gas R? When ethanol undergo complete combustion, gas R, the gas that is produced is carbon dioxide, and it's carbon dioxide because the product of combustion complete one is carbon dioxide and water. Therefore, the gas is carbon dioxide. Process Q. Now, ethanol turns to ethene through dehydration. So this is called dehydration, removal of water. So this is dehydration. Okay, so alkenes are converted to ethanol, alcohol are converted to alkenes through dehydration. Write the balanced chemical equation for the combustion of ethanol. Write the balanced chemical equation for the combustion of ethanol. We've written it already. So look at these questions, how they are repeated. So here we're writing the combustion reaction equation, balanced one. Even here, they're asking us to write the balanced chemical equation for combustion. So you should take note even as you study. Make sure that you can write the balanced chemical equations on all the hydrocarbons or all compounds when they undergo combustion. Okay, to help you. All right, let us look at the other part of, so the equation here, please just refer to this one. It's the same one. So let us look at question 12. Okay, let us look at question 12. So question 12, study the following sequence of reactions. So glucose is converted to ethanol, and ethanol is converted to ethene, and now ethene is converted to polyethylene. So what we've discussed is that glucose can be converted to ethanol. What process is that? And when ethanol converts to ethene, what process? When ethene converts to polyethylene, what process? So these processes, you should know them. Okay? So what is the first question? That is A12. What name is given to the process by which glucose changes into ethanol? What process do we give to this one? So the process is called fermentation. Fermentation. Okay? So that is the answer there. B2, name the enzyme responsible for change in above. So the enzyme is found in yeast, because yeast is the one that is added to glucose to ferment it or to produce an alcohol. So the enzyme is called zymase. Okay? Zymase. Then the next question, what gas is produced during this process? So the process of fermentation, what gas is produced? Okay, so the gas that is produced in this case is the carbon dioxide. Name the process and the catalyst used when ethene changes into polyethylene. So the process is called additional polymerization. Additional polymerization. Okay, then now what about the catalyst that is used in this case? So the catalyst is called the Ziegler-Nattau catalyst. Okay, titanium chloride, titanium chloride. Okay, these are a compound of titanium. Then you also have compound of aluminium. So those are the catalysts that are used. Draw the structure of polyethylene with 3 repeating units. So we are drawing now a polyethene with 3 repeating units. Polyethene. So how many ethene? We have 2 of them here, plus another one. So that is what it means. If you add these ethenes, if you add them, these are hydrogens. If you add these, you're going to have a long chain with how many carbons? You're going to have a long chain with 1, 2, 3, 4, 5, 6. 6 carbons. So it will be like this. Here you leave the opening, showing that more bonds or more ethene can attach. They've just asked you to show 3. So this is how it is shown. So this is it. Okay, so this is called polyethene. All right. The polyethene is non-biodegradable substance. Explain what it is meant by non-biodegradable or non-biodegradable. Okay, what does it mean, non-biodegradable? So this means that they cannot easily be destroyed by bacteria. Okay, non-biodegradable means they cannot be easily broken down by bacteria, or cannot easily be disposed by the biological mean, which is use of bacteria. And the question asks, state the effect of such polymers on the environment. So the polymers, the effect is that they cause air pollutions in the case where they are bent. Since we are saying these cannot be disposed easily, so the only way of recycling them could be burning, and burning produces the smoke, which contains some gases, greenhouse gases.